In this task, you'll learn how to perform a join. Your organization has diabetes and morbidity counts by neighborhoods in Baltimore. They're not stored in a database table and are not currently associated with a GIS layer. Therefore, in their current state, you can't display the data on a map. You'll join the data to the neighborhoods layer so that this data can be rendered on the map. So here I have QGIS Desktop open with the QGIS map document I saved at the end of task 1. I'll start by adding the table. I'll click the Add Vector Layer button, click the Browse button, and I'll navigate to the Lab 3 data folder. In the Open and OGR supported vector layer window, I'll set the file type filter to All Files and choose the Baltimore City Diabetes Neighborhood DBF. I'll click Open and Open to add it to QGIS Desktop. The table is added to the Layers panel with a table icon. There's 2 requirements for a table join. The 2 tables need to have a common field upon which the join will be based, and 2, there needs to be a cardinality of 1-to-1 or many-to-1 between the attribute table and the standalone table. Now I'll open the table by right-clicking on it and choose Open Attribute Table. The table has 2 columns, one with the neighborhood name and one with the population diagnosed with diabetes. Now that I'm more familiar with the data, I'll close the table. Next, I'll open the attribute table for the neighborhoods layer. There's a column with the name and many columns of socioeconomic data from the 2010 census. Now that I'm familiar with this data, I'll close it. In this case, there's a column containing the neighborhood name in both tables. There's 271 records in each table, meaning there's a cardinality of 1-to-1. We've met the requirements for a join. To start the join, I'll open the layer properties for the neighborhoods layer and switch to the Joins tab. I'll click the green plus button to add a join. The Add Vector Join window opens. The join layer is the table I wish to join to the neighborhoods layer. I'll click the Join Layer drop-down and select the Baltimore City's Diabetes Neighborhood table. As I discovered while investigating both tables, the field that the join will be based on is called Name in each. So I'll select the Name field for both the Join field and the Target field. I'll take the remaining defaults and click OK to create the join. The join now appears in the Joins tab of the Layer Properties for the Neighborhoods layer. I'll click OK to close the Properties window. To see the results, I'll open the Attribute table for the Neighborhoods layer. I'll scroll to the right to see the new column appended to my attribute table. Its name is the Join Layer table name followed by the column name. Joins only exist in virtual memory within the QGIS desktop document. The data aren't permanently attached to the Neighborhoods layer attribute table. To preserve the join outside the map document, I'll right-click on the layer and choose Save As. I'll set the format to Esri shapefile. I'll then click the Browse button and save the new layer to the Lab 3 data folder. I'll name it neighborhooddiabetes.shape. And I'll click OK. The new layer will include the attributes appended via the join. To investigate the result, I'll use the Identify Feature tool. I'll select the Neighborhood Diabetes layer in the Layers panel, and I'll click on the Identify Features tool. Once I've selected this tool, I'll click on one of the neighborhoods on the map. I'll expand the window so I can see the fields and associated values. This tool gives you an interactive way to explore the attribute values. As handy as the Identify Features tool is, it'll be much more powerful to be able to see all the data on the map. So I'll work on styling the data next. I'll open Layer Properties for the Neighborhoods Diabetes layer, and I'll select the Style tab. So far, we've only explored the single symbol renderer. This time I'll click the drop-down to the right of single symbol, and I'll choose the graduated renderer. This allows me to classify the features on the map by a numeric attribute column. I'll choose Baltimore City D as the column. Then I'll click the drop-down next to the color ramp, and I'll choose Reds. I'll set the mode to quantile equal count. This method of classification tries to put an equal number of features, neighborhood polygons, in each class. I'll leave the number of classes at 5. Now I see the columns for the values and the legend. The legend column contains what will be seen on the map legend. There's some extraneous decimal values. To clean this up, I'll double-click on each legend value to edit it. The top class can just be changed to 0. Then the next can be edited to read less than 105. The bottom class can be changed to greater than 498. I'll also remove the decimal places for the middle classes. I'll click OK to close the Layer Properties window. Now I can visually see the data that had been stored in a tabular file on a map. Now I'll do some cleanup. Since the data are now attached to a new version of the neighborhoods layer, I no longer need the original join. To remove the join, I'll open the Layer Properties and go to the Joins tab for the neighborhoods layer. I'll select the join and remove it by clicking the Remove Join button. The join was an intermediate step. I'll click OK to close the Layer Properties window. Finally, I'll click on the Baltimore City Diabetes Neighborhood table and remove it. In the final task, I'll geocode some address-based data.